Hello everyone, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. Welcome to my video. So basically this is a lecture video on the topics on synchronous machine. Okay, so my name is Dr. Nur Zulaili binti Muhammad and this is my email address. So you can just feel free to email me whenever you have a question regarding the content of this video. Okay, so let's move to the list of contents that we are going to cover in the chapter 5. So first of all, we are going to see the construction of the synchronous machine. Okay, so we are going to go through some brief introduction on the synchronous machine. Okay, and then after that, we are going to see the structure of the synchronous generator. Okay, so as far as you know, the synchronous machine, it can be either synchronous generator or it can also be synchronous motor. Okay, so for the synchronous generator, we are going to see the principal operation of the synchronous generator. Okay, and then after that we are going to see the equivalent circuit model for the synchronous generator. Okay, and then we are going to see on how to draw the phasor diagram for the synchronous generator. Okay, and then after we're done with the generator part, then we are going to continue on the synchronous motor. Okay, so same goes to as per here. Okay, we are going to see the principle of operation of the synchronous motor, and then we are going to see the equivalent circuit model for the synchronous motor. Okay, and then after that we are going to learn on how to draw the phasor diagram for the synchronous motor. Okay, and then after that, in terms of the performance of the synchronous generator and synchronous motor, we are going to learn on the concept of voltage regulation for the synchronous generator and also synchronous motor. Okay, and then after that we are going to see in details on the concept of power flow diagram and also torque equation for the synchronous generator and also synchronous motor. And then finally we are going to see on some theory on the starting of the synchronous motor and also the speed control of the synchronous motor. Okay, alright, so basically in this video, we are going to cover only the first subchapter, which is the construction of the synchronous machine. Okay, so for the rest of the subtopic, we are going to cover in the next following video. Okay, so now let's move to the first subtopics of chapter 5, which is construction of synchronous machines. Okay, so some introduction on the synchronous machine. So basically, the synchronous machine is designed to operate at synchronous speed, which is ns. So that's why we call it as a synchronous machine. Okay, so unlike the induction machine that we learned in the previous chapter, okay, if you still remember, for the induction machine, we have two different speed. We have rotor speed and also we have synchronous speed. But for the synchronous machine, we only have one type of speed, which is synchronous speed. Okay, alright. Okay, and then the synchronous machine can be used to operate either as a synchronous generator or it can also be operated as a synchronous motor. Okay, so rather than synchronous generator, sometimes we also can call it as a alternator. Okay, alright. But basically, even though the synchronous machine can be operated as a synchronous motor, but it is primarily used as a generator. Okay. Okay, so in terms of the construction of the synchronous machine, so the typical synchronous machine consists of two parts. One is stator and the other part is a rotor. So it is same as per induction machine as well. Okay, so basically this is a illustration, a schematic illustration of a synchronous machine. Okay, so here you have a stator part. Okay, stator part is the one that static, does not move. Okay, and then you have rotor in the middle. So rotor is the one that moving in the machine. Okay, alright. So the first picture represent the synchronous machine that made of the salient rotor structure. Okay, so the structure we call as a salient rotor structure. But here, this one also this one also represent the synchronous machine, but with round rotor, or we can also call it as a cylindrical rotor. Okay, so basically this is the two different type of rotor for the synchronous machine. Okay, so basically it has a stator part and also rotor part. Okay, alright, so here is the air gap. So here also air gap. Okay. Okay, so for the windings at the stator and also rotor, for the synchronous machine, it has two types of winding. Okay, so the first winding at the rotor side, we call it as a field winding. Okay, and then for the field winding, it will create a magnetic field. Okay, and then for the stator part, we call it as a armature winding. Okay, so basically the voltage will be induced on the armature winding, and then the armature winding usually always connected in Y connection preferred. Okay, why? The reason why is the voltage per phase is only 1/3 for the Y connection, or it can be considered as a 58% of the line voltage, so it will be permitting a reduction in the amount of dielectric insulation. Okay, so under load, the voltage can become distorted and no longer sinusoidal due to the third harmonic voltage. So when we have a Y connection, the third harmonic voltage cancel between the line to line voltage, but with a delta connection, the third harmonic voltage will act and appear on the line to line voltage. Okay, so that's the reason why the armature winding will be always connected in the Y connection preferred. Okay, so in terms of the rotor type, okay, as per we see in the previous slide, we have two different types of rotor. So the first one we call as a salient rotor structure. Okay, synchronous machine with salient rotor structure, and this one is a synchronous machine with a round or cylindrical rotor. Okay, so the first one is the salient pole, this one. Okay, so for the salient pole type, it is driven by the low speed hydraulic turbine. Okay, and then for this type of synchronous machine, it requires a large number of poles. Okay, and then since it requires a large number of poles, okay, and also due to the shape of the rotor, so that's why this type of rotor possesses a large diameter to provide the space for the poles. Okay, all right. So the next type of rotor is a cylindrical type. Okay, this one, or we can also call it as a non-salient rotor or round rotor. Okay, so for this type of rotor, it is driven by the high-speed steam turbine. Okay, and then basically for the number of poles, it cannot be less than 2. Okay, so if you compare between the round rotor versus the salient rotor structure, so this type has a smaller size compared to the salient pole. Okay, so I think that's all for the topics on the construction of synchronous machine. Okay, so in the next video, we are going to continue to learn on the principal operation of the synchronous generator and also synchronous motor. Okay, so thank you for your time. Thank you for watching my video. I'll see you in my next video. Okay, bye.